Hi, welcome to part 2 on taking a look at particle motion. So today we are going to look at particle motion. We're going to look at more of a graphical sense for us. And yesterday we looked at particle motion dealing with functions. Today we're going to solve particle motions from a graph. These are very popular on the AP, so remember, show your work. So the figure below shows the velocity. So even though it mentions velocity, I am going to mention that this is my velocity graph. And the question says, when is the particle moving up? When is the particle moving down at rest? And then they want us to justify our answer. So because this is my velocity graph, I can kind of mention my parts. Remember, if we are above, this is like my derivative, right? So if we're above, we're saying that the slope is positive, or in other words, that we have positive velocity. If we're below the x-axis, or the t-axis in this case, we have negative velocity. And if we're on the x-axis, that's where our velocity is 0. So the question is moving, when is the particle moving up and down at rest? So of course, moving up, that is positive velocity. Moving down would be negative velocity, and at rest would be velocity at 0. Justify our answers. We are going to use sign charts. So the first thing we're going to have to look for are our critical numbers. Where is the velocity equal to 0? Remember, velocity is a derivative. This is really s prime of t. It is a derivative. So we're looking for where velocity is 0. Now again, because this is the actual velocity graph itself, we can include the endpoint. So we would get t equals 0, 2, 7, and 10. And I'm going to make my sign chart right here. Be careful, we are restricting our domain, it looks like, between 0 and 10. So I'm going to go from 0 to 10. On top is my velocity. And how is that going to affect my position? Putting in our other critical numbers, 2 and 7, I'm going to look at their signs. So I want to look at the signs for the velocity. So between 0 and 2, we are above the x-axis. So we say we have a positive velocity, so we are going up. We're moving up like a disco duck. Between 2 and 7, the velocity is negative because we're below the x-axis, so this is moving down like a disco clown. Between 7 and 10, we are again above the x-axis, so this is a positive velocity, so we are moving up. So now I can answer the questions. When are we moving up? Well, we're moving up between 0 and 2, or between 7 and 10. And that is because the velocity is greater than 0. We are moving down between 2 and 7, and that is because our velocity is less than 0. Remember, don't use the word it. And you can use s prime if you like, but don't use s prime, okay? All right. And now we're not done because I do say at rest. So we're at rest when the velocity is 0. That is 0, 2, 7, and 10, because the velocity there is 0. Kind of ran out of room for that one. All right. The next one is an interesting question. It asks, when is the particle moving at a constant speed? So let's define what speed is for us. Speed is the magnitude of velocity. And what we're looking, and so what that really means is that all the values would be positive. Speed cannot be negative. That's why a speedometer always measures positive. Next time you're driving your car, put it in reverse and look at your speedometer. Well, safety-wise, have somebody else look at your speedometer. It'll be positive. But if I'm moving at a constant speed, if the speed is constant, what that is telling us is then the acceleration has to be 0. So if I look at my graph right here, I can find where my acceleration is 0. Remember, we talked about this beforehand. It is where the slope of velocity is 0, or where the slope where velocity isn't changing. And it looks to be between 3 and 6, where acceleration is 0 right there. So we would say between 3 and 6, and that is because the velocity, I can't write that out there, there we go, because the velocity is not changing, or v prime of t is 0 right there. And that's what we're looking for in our answer. All right, speaking of acceleration, part 3 says, when is the particle's acceleration positive? When is the acceleration negative and 0? And justify our answers. So we know acceleration as the derivative of velocity. So we want to find out when that slope of velocity is positive, when the slope of velocity is negative or 0. So we're looking at v prime of t, which is a of t. We want that to be 0, or d and e. And I can find those pretty easily. So when I go back up here, we already kind of mentioned it. Remember, for this one, we are looking at the slopes of our velocity graph. So I can get that from looking up here. So where my slope d and e, right here, this long piece, we'll talk about that, and up here at 8. So it looks to be at about 1, the range 0 to 3 to 6, and at 8. So when we go ahead and do our sign chart, between 0 and 10, here's my acceleration, and I'm going to put these in 1, 3 to 6, and 8. Now the whole domain 3 to 6 is 0. That acceleration is going to be 0. The slope is 0 there. Remember, we're looking at v prime of t, the slopes. So between 1 and 2, the slope is positive. So we're accelerating in positive. Between 1 and 3, negative. Between 3 and 6, that whole slope there is 0. Between 6 and 8, positive. And between 8 and 10, negative. So where is the acceleration positive? Well, between 0 and 1, or 6 to 8. And that is because our acceleration is greater than 0, or v prime of t if you want to. Acceleration is negative on 1 to 3, or 8 to 10. We're looking 10. And that is because our acceleration is less than 0. And when is the acceleration 0? Or, that's easy to find. We can say 3 to 6. And that is because the acceleration, of course, I guess is 0. I know, kind of we'd write it that way. But, now be careful. Note, I did not include 1 and 8. Because the acceleration is not 0. It just does not exist up there. Alright, these are our fun ones. The next question asks, when is the particle speeding up or slowing down? Now we mentioned this yesterday. For both of these, we are going to need velocity and acceleration. So let's deal with velocity first. Where is velocity 0, or d and e? We got those from part A up here. 0, 2, 7, and 10. I'm going to write those down. T equals 0, 2, 7, and 10. When is acceleration 0? We got them from part C. 1, the domain 3 to 6, and 8. We're going to do our double sign chart here. We talked about this yesterday. Go look at the video. It's an amazing video, if I must say so myself. So we're going to write out a double sign chart. Be careful, my domain is still from 0 to 10. 0 to 10. On top is my velocity graph. On bottom is my acceleration. So velocity, 0, 2, and 7. The bottom, 1, 3 to 6, and 8. Now I want to do my signs. Now I already have my signs for both of these. For example, velocity was positive, negative, positive. So I can just go and write that in there. Positive, negative, positive. Acceleration was positive, negative between 1 and 3, 0 between 3 and 6, between 6 and 8, positive, and then negative from 8 to 10. So if I'm looking for where this is speeding up, remember speeding up, they are the same signs. I'm slowing down, we want opposite signs. So we are speeding up when the signs are the same. Ah, look, between 0 and 1, they're both positive. Look again. Ah, look, between 2 and 3, they're both negative. And is there one more? Yeah, it looks to be between 7 and 8. We're going to talk about the 3 to 6 in just a moment. And this is because acceleration and velocity have the same sign. We talked about this again yesterday. We want them to be the same signs because to speed up, your acceleration and your velocity both have to be pointed in the same direction. To slow down, acceleration and velocity have to be in opposite directions. That forces you to slow down. So slowing down, were they the opposite signs? Looks to be between 1 and 2, or 6 to 7. We'll talk 3 to 6 in a second. 6 to 7, or 8 to 10. And that is because acceleration and velocity are opposite signs. Now, you might be wondering, well, what about 3 to 6? Well, 0 has no sign attached to it. And because 0 has no sign attached to it, it's not speeding up or slowing down. This is when you're moving at a constant speed. This is kind of like when you put your cruise control on your car. Your acceleration is 0. You just move at the same speed the whole time. So because my acceleration is 0, we're not speeding up or slowing down. Here's an interesting question. Could you have a positive acceleration but 0 velocity? Interesting. The answer's in here if you want to look at it. Alright, for the next part, we want to graph the particle's speed. Now this is one that always gets people. Remember, speed is the magnitude of velocity. So it's the same exact graph. It's going to be the same graph, just positive values. So if I go back up to my chart, my graph up here, see here's my velocity graph. Well, if I wanted to get speed, anything positive stays positive. Anything negative becomes positive. You might remember this from pre-cal. Your teacher would say you're just going to flip the negative values. So if I wanted to graph this, here's speed, not drawn to scale, between 2, 7, and 10. Those are my critical numbers, 0, 2, 7, and 10. Between 0 and 2, I'm going to have the same graph. It goes up, goes down. Now, between 7 and 10, it's going to look exactly the same. Whoops, missed it. There we go. But the difference is between 2 and 7. See, right here is negative. They get speed. That becomes positive. We learned that in Ferris Bueller's, right? Remember they tried to drive that car backwards, right? To cut off the, to make the odometer go backwards? Doesn't happen that way, so we're going to flip that. So this gets flipped, like so. And there's speed. Now, to graph acceleration. Acceleration, remember, is the derivative of velocity. Therefore, this are the slopes. So I look. I'm going to look at the differences. The slope, I'm going to graph the slopes of velocity. Between 0 and 1, the slope looks to be 3. The slope on 0 to 1 looks to be 3. The slope on 3 to 6, sorry, let me fix that. The slope on 1 to 3, from 1 to 3, there we go, from 1 to 3, it looks to be going down 6 over 2. And that's going to become, so it's down 6 over 2, which is negative 3. The slope on 3 to 6, well, if I look here, go back up here, between 3 to 6, it looks to be 0. So that's our horizontal. Remember, we're looking at the acceleration, so we're looking at the slope. So between 0 and 1, the acceleration is 3. The slope on 6 to 8, well, let's go back up here to our graph. Between 6 and 8, it's up 6 over 2. So it's 6 over 2, which is positive 3. And then the last one, the slope on 8 to 10, we go up here, between 8 and 10, it looks to be down 1, down 3 over 2. That's negative 3 halves. So if I wanted to graph this, on 0 to 1, the slope is 3, not drawn the scale. From 0 to 1, the slope is 3. Now notice, they're always going to be open. And the reason they're open, very simple, is because that's a corner, not differentiable. We'll talk about that in a second. So then so this is my acceleration graph. These are all constant values, so there's going to be horizontal lines. From 1 to 3, we said the slope was negative 3. Between 3 and 6, the slope was 0. Again, they're always going to be open. Okay? They're all going to be open. Okay? And that deals with differentiability. Then from 6 to 8, the slope was 3 again. And then from 8 to 10, there's negative 3 over 2. Negative 3 halves. Whoops. 8 to 10. There we go. And again, they're all going to be open because of F, or the velocity, is not differentiable at those points. So keep them open. All right, I hope you enjoyed this video. I'll see you guys in part 2. We're going to take a look at one more example.